Hello students, it's Dr. Sansom, and today I want to talk to you a little bit about polyatomic ions. Now, most of what I'm going to talk about is how they are named and how to memorize the names and structures of the polyatomic ions, but I'm also going to just introduce the idea of a polyatomic ion and what it is. So a polyatomic ion is a group of atoms that are covalently bonded. That is to say it's like a molecule. There's multiple atoms that are there and they are covalently bonded together. They're sharing electrons and that have a charge. Most of the polyatomic ions we're going to talk about are negative. We have one positively charged polyatomic ion as well. I'll start with a really simple example, and the first simple example I want to talk about is hydroxide. Hydroxide is OH minus, is how we normally write it. The way it's bonded is you have a hydrogen and you have an oxygen. The oxygen has 6 electrons around it, and it's the one that has the negative charge. So structurally, you can see there's this covalent bond there, okay? And it has a charge. It has an extra electron. Normally, oxygen would have 6 electrons, hydrogen would have 1. That would only be 7 electrons, but there's 8 electrons in our structure, so there's an extra 1 there. So that is hydroxide. Hydroxide is a very common polyatomic ion, so you probably just need to memorize the name of it. It's also not related to any others. I want to start with phosphate, which is PO4 3-, in terms of helping you with names here. So one rule that we have with names is that things that end in "ate" are going to have one more oxygen than things that end in "ite." So if we have phosphite, which is also a polyatomic ion, that one's going to be PO3 3-. Notice it has one fewer oxygen atoms than phosphate. So 8 and 8 are related that way. The other thing that I want to point out here is that we can, for phosphate, we can add hydrogens to this. So we have something that's called hydrogen phosphate. And hydrogen will be an H and also a positive charge. So instead of PO4 3-, I'm going to have HPO4. So all the atoms that were there before stay, but I'm adding a hydrogen. And now instead of 3-, it's going to be 2- because the hydrogen has a positive charge. So it's going to reduce the magnitude of that negative charge on the phosphate when we add hydrogen. We can also add another hydrogen and we can get dihydrogen phosphate. That's H2PO4, and because we've added 2 hydrogens, it'll only have a 1- charge. So these are 2 of the main rules that are going to help you memorize more ions with less work, which is 8 has 1 more than 8, and if I add a hydrogen, it adds an H and a plus. So it changes the number of hydrogen atoms that are there and also the charge on the ion. The next one we'll do is sulfate. This is SO4 2-. And like phosphate, sulfate has the less oxygenated sulfite, which is SO3 2-. And we can also have hydrogen sulfate, HSO4-, and hydrogen sulfite, HSO3-. Continuing with this pattern, we're going to have carbonate, CO3 2-, and its companion, hydrogen carbonate, HCO3-. Sometimes this is also called bicarbonate. Likewise, bisulfate, bisulfite, etc. Another very common one is nitrate, NO3-, which has its partner NO2-, nitrite. Then there are the 4 that have chlorine. We have ClO-, ClO2-, ClO3-, ClO4-. This one is called hypochlorite, chlorite, chlorate, and then perchlorate. So just like before, we've got the ite and ate relationship. The other thing we've introduced here is hypo and per as prefixes that are going to indicate hypo means less than, so you have one less oxygen, and per means one more than. You've probably seen hypo and hyper in other contexts in science, so that's what those mean, is less than or more than. So they have less oxygen or more oxygen than the corresponding chlorite or chlorate, respectively. Okay, now on top of these, there's a few that we have to just memorize and know what they are. So we'll start with those. We've got acetate. This is sometimes written C2H3O2-, or sometimes written CH3COO-. Both of those are acceptable. The second one gives you more information about the structure of that ion, so I prefer that one, but you'll often see it written in formulas C2H3O2. Okay, we have cyanide. This is Cn-. We have hydroxide, which I already mentioned. We have permanganate, MnO4-. Now, it does have that prefix per, but there aren't any stable polyatomic ions with less oxygen than this one. We have azide. This is N3-. This one's kind of a funky one because it's only made of nitrogen atoms that are bonded together. And we'll have SCN-, which is thiocyanate. We have C2O4-2-, which is oxalate. CrO4-2-, chromate. And there's dichromate, which isn't exactly double, so it's a little bit confusing, but there's 2 chromium atoms, 7 oxygen atoms. We have silicate, SiO3-2-. This is sort of analogous to carbonate, in case that helps you, because silicon is underneath carbon on the periodic table. And we have disulfide, S2-2-. And the last one is ammonium. This one is actually our only positively charged polyatomic ion, so it is unique. Now, I'm going to scroll back to the top, and I'm going to kind of say, which of these ones do we need to know? I would say you need to know all of these guys that we went through at the beginning. You're going to see all of them all the time, all over the place. They're very common. I'd say you need to know these chlorine-containing ones. You will see those frequently. Acetate, cyanide, hydroxide are really common. And ammonium is pretty common. Now, these other ones are in the nice to know category. So all of these permanganate, azide, oxalate, etc., those are in the nice to know. I'm less likely to use them. They're a little bit less common. You won't run into them as much. You should make yourself familiar with them. It's worth it to know what they are. But the other ones that I've indicated, the ammonium, the acetate, cyanide, hydroxide, the chlorine-containing ones, and then all the derivatives of phosphate, sulfate, carbonate, and nitrate are ones that you're going to want to know. Okay, that's everything for our polyatomic ions. I hope that's helpful, and I hope you have a great day.